Today we're going to talk about the animation system. We're going to cover most of the feature of the animation system, but with some like being able to use text for frames, we're going to leave it on the side for now unless there are questions at the end. Mostly because there is nothing very special about it. Every frame of animation is a graphic, and graphic can be either a text or texture. So I don't feel like it's really relevant to the animation system itself. But if there are questions, I will cover them at the end of the session. We are going to start by creating a new project. We're going to call it anim demo, and we're going to use scroll because we're going to add a little logic to move the characters around, but we won't need anything else. So the project is being created, and now let's open it. So I should have already, here we can go to any demo, build, Windows, and we're going to use Visual Studio. Okay, and just config. All good. So I'm going to build the project in debug and in release, which are the two options we're going to use today. If we start the release one, right now you should not see anything. You might hear like a little sound. It's because we need to adapt the project for streaming. That's not going to be very long. We're just going to remove this. We are not going to use spooning because all our assets are pixel arts. I'm going to add proper credit at the end in the description for every art assets we're going to use. They are all free and under either Creative Commons or similar licenses. What we're going to do is ask Orcs to use a second monitor, which I use for streaming, and now you should actually have the window and it should appear in the stream as well. On top of this, the console is a bit small, so if I remember correctly, set render console font scale. I think 2 was a good value. 3 is actually not too bad. 4 is too big, so we're going to keep 3. We're going to add it here. So render console font scale equals 3. Okay. And now we should be set up. Perfect. So last time I had an issue with my headset turning off after half an hour. I removed that feature from the driver of the headset, but just in case, I'm still going to keep the tiny sound at the beginning when every time I start the application. Hopefully it won't be too annoying for you. It's just so that make sure that there's enough input so that my headset will not turn off as a double protection. So we're just going to keep the sound here, but what we can do is actually like lower the volume, like volume of the sound 0.3, so that it doesn't annoy everyone. The object we don't need anymore, and everything else can go away. Now, what we're going to do is copy our assets. We are going to go into our data, texture, and here we're not going to use the logo anymore. However, we're going to use this style set here, these characters, and the smoke effects. We're going to copy everything here. All good. And we're also going to use some audio for animation and sound synchronization. And we're just going to use like Footstep that are coming from this free SFX pack. Now that we have all these assets, we should not need this anymore. We need to add them so that Orcs can find them. So for the sound, we are going to set in the path to the root of our asset, which is here. We want FreeSFX, KeepInCache. We could keep the backslash, but I like when everything is consistent. So with this, I should be able to locate like any footstep. Let's try this guy here. And let's see if I can locate it. So if I add resource, oops, sorry, it's a bit too low. It's a bit too big, actually. You know what? This window, we're just going to change its size. screen width. We're going to go in 1080p. Screen height. Much better. Okay, so let's try to locate that resource. It's a sound resource, and it's in Footstep, retro Footstep wave. There are spaces, so we need to quote the whole thing. And it's found. So sound resources are located. Now let's double check that we did our job correctly for the textures. The first one is this little guy here, which seems to have the same name, so we're just going to copy this. And for texture, we want to have data texture, this guy here, and I believe it's .png. I think that's correct. And let's see if we can actually load this. Actually locate this resource, locate in texture. We want to locate this PNG, and it's not working, so I made a mistake somewhere. Texture, and we want. Oh wait. Oh, yeah, that's terrible. Okay, that the path is not correct. Data textures. I'm not sure why I put the PNG there. Sorry, I'm a bit tired. Let's try this again. Locate texture, and now it's working. Next one is Kings and Pigs sprites. So let's try this. Kings and Pigs and sprites. Next entry, the texture, Kings and Pigs sprites, and we want to locate 01 King Human, and we're going to use something like I don't know, the idle. So 01 dash King Human. Resource, locate, texture, 01, oops, there are spaces, I believe, 01, how was it called? 01, no space, dash, king, human, name of the texture, oops, wrong key, and that's working, and last one will be our smoke FX, and we just want this part here. So going to add it. I'm not sure why Visual Studio sometimes lose the edition. Okay, data, texture, and there we go. So we want to have this sheet here. And let's see if we can locate it. Resource, locate, texture. Yeah, I forgot the quotes. Textures. And everything is good. Okay, we have all our resources. Now we can actually work on the animation itself. We're going by creating a base character, and this base character, we're going to give it a scale because you'll see the sprites are quite small. We're going to scale it by 4, and we're going to give like a pivot at the bottom of it. Lastly, we're going to give it an animation set, and let's call it character AS. Character AS. And now we're going to define this animation set. So the first thing we need is like the key duration, because it's common to all the frames of all the animation inside this set. So we can put it at the beginning of the animation set. The part that needs to be understood is that inheritance is made automatically for you when you use animations. A frame will inherit from its animation, which it will inherit in turn from its set. So if you define something at the set level, it will be the default value for all the animations inside it and all the frames inside this animation. But you can, of course, override it at the animation level or at the frame level, which is something we're going to do after to illustrate this. But this allows you to not have to repeat this property for all the common parts. Like here, we know that all the frames are going to last 0.1 seconds. It's a 10 Hz animation, and there's no need to do it on every single frame or even at the animation level. We just do it at the animation set level, so it will be done for all the animations. We are going to start with our little dungeon tile set. Let me open this, and I believe you can see it now. So it's a cute one. We're going basically to use different characters, and there's like a stray animation, one walk, one idle, and one hit animation, and we're just going to use that on different characters. So here we see that for this character, actually, you know what? Let's not start with this style set because we're going to work with style set. We're going to first go back to how we can seed from different kind of sources. So using sprite sheet or texture atlases is one way, but we can also source seed animation from separate textures. And here we actually have all the separate frames for all the characters and objects that you've seen in the spreadsheet. This is usually not how you want to ship your games, especially if you have like hundreds or thousands or dozens of thousands of them, because it will take a while to load all these separate files and it's not efficient in memory. However, in development mode, maybe you, like your artist is going to give you like a separate file, so you're going to use something coming from like a free pack, like I'm doing right now, and that's what you're going to get. And you still want to be able to use them without having to pack them yourself or use a separate tool like Texture Packer. And Orcs support that as well. So we're going to start with this first. We're going to use separate texture for each frame, and we're going to see how it works. Something important to know also in Orcs is that there are two template files that ship with Orcs, and they're also part of any project that you create. One is called settings template, and you can see that at the beginning of both files, there's like a lot of commands, and this is the syntax of the config. So like config is using the base of INI syntax, which is like key value pairs, like key equals value. But on top of this, Orcs add the concept of inheritance, concept of randomization, concept of commands, and things like this. Just give me a second. So these two files are the kind of they are very useful no matter what your experience with Orcs is, because it's what defines all the properties that Orcs recognize, and they are always kept up to date. Every time I add modified properties inside Orcs, those files are also modified at the same time. So if you look at the settings template file, you can see that you have everything that are like settings that are read either at loading upon init, or like settings that are global and affect like the entire Orcs experience. Like for example, the scaling of the font inside the console is one of those, and it's actually, if we look at the render section, you can see that we have the console font scale, but the entire console is modable. You can modify the colors, the alpha, the text, and things like this. So this is useful also for like the display. That's where we, at the beginning, we said that we wanted a 1080p default resolution to begin with. You can of course change the resolution at runtime, but this is going to be the initial resolution when you start your application, your game. That's where we define where to spawn the window on the second monitor. By default, it will spawn on the primary monitor, and so on and so forth. So these are very useful. That's also where we did the resources, where we gave the path for the kind of resources we wanted. Those are called groups. So Orcs uses three groups: config, sound, and texture, because that's the kind of assets Orcs is using at the moment. But you can add your own groups for that, and maybe we'll cover that in a different live session. There is no limit on the kind of groups you can have. You can have as many as you want, and you can name the way you want. So here is basically just the storage for each group, and it's a priority storage. So if an asset, if your resource is looked for sound, if we're searching a resource for sound, it will first look into the first storage. If it's not found, it will go into the second, and so on and so forth, until it's found. Then this location will be cached so that we don't do this every single time. And those locations, right now, they are supported to be coming from the file system, your local file system, or like remote path if you're using things like UNC path to have like a local network share or these kind of things. But you can also get resources from like APK on Android. This is native to Orcs. And there are some modules, some extension to init that expand that so that you can have like assets coming from remote, from a web server, or coming from a zip file, and you can also write your own way to accessing assets. I'm not going to go into much more detail. It's just to explain a bit what I was doing at the beginning when I was adding all the storage here. Basically, when I'm looking for a texture, it's going to go in this order. It's going to look for the name I'm giving it and try to find if in all this storage there is a way to access it. And yeah, so let's not dive too much into detail into this one. Creation template is what we're going to use today. It's everything that can be instantiated. So like an object can be created and instantiated, like a graphic can be, and of course an animation set, animation, and animation frame. So if we look for animation, here we go. And you can see that there's a lot of comments. Right now what we want to do is define our animation set. We already defined like the key duration. We define it at the animation set level because we want the same for all the different animations. And we now want to be able to source different animations. So you can see that here there's 3 ways to define animation. One is calling it empty, and it just creates an empty node in the animation graph, which can be useful for like some trick when you want to use target, but you want to have different paths. I'm not going into this; it's a bit too much into detail, so I'm just going to cover the ground base first. But sometimes know that it can be useful to have like an empty animation in the graph for navigation purposes. And then there's these 2 things. One is taking a string and an int, and the other one is taking 2 strings. The one that takes 2 strings is actually going to, the first string is going to be the base name, and the second string is going to be the extension, and that's what's written here. Basically, that's how you can seed from separate files. You're going to give the base name of the files, and then the extension, and then Orcs will just increment digit inside it, starting with 1, 2, 3, 4, 5. And you can also define if you want any prefixes, I mean any leading 0 in that digit. So like how many digits will be used for animation frame suffixes. It defaults to 0, and that is just going to be 1, 2, 3, 4, 5, and when it reaches 10 there will be 2 digits, when it reaches 100 there will be 3 digits, but there's only the minimum amount of digits. But sometimes your frames have written like 001, 002, 003, and that's where you define how many digits there is in these fixed numbers, and it will add a leading 0. So if you say there's 3 digits, it's going to start with 001, 002, and when it reaches 10, it will be 010, and so on and so forth. In our case here, if we look at this, you can see that there are no leading digits. Like if we look at the night here, you can see that there's F0, F1, F2, F3, but there's no leading digit. So we are not going to use this property, but know that it exists and it's useful. So we're going to use this here to define our animations. But first, we're going to keep it simple. We don't want to have like something complex, just for the sake of time. So we're just going to define 3 animations: an idle, a walk animation, and a hit animation. So how we do this? First thing, we need to define an entry point, the first animation that's going to be played on the character if it's left to its own device, and we're going to call it idle. So our start animation is idle. Now we need to define the graph, what kind of transition we can do from idle. So from idle, and that's the syntax, you put an arrow at the end of it, we want to be able to transition to idle itself, like mean that we are going to loop. We want to be able to transition to walk. However, when we transition to walk, we want to interrupt the idle. We don't want to finish the current cycle. We want to interrupt it and go directly to walk. And the syntax of this is adding a leading dot. And finally, we want also to be able to transition to hit. And same thing, we want to be able to interrupt the idle. And we're going to go immediately to hit. But we also want that if we say that the target animation is hit, we don't want to stay in the hit like cycle. We don't want to have hit, 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 hit. So we're going to reset the target when we go into the hit. So every time the transition from idle to hit is going to be taken, the target animation is going to be reset. And to do this, it's the exclamation mark. Now from walk, we want to be able to transition to walk as a cycle. We're just going cycling around it. And we want also to be able to transition to idle and interrupt the current walk cycle. But we also want this transition to be the highest priority, meaning that if we are not trying to actively stay inside walk, we want to transition back to idle. And this is with the plus sign. So here that means that as long as we have a target that is set to walk, we will remain into the walk and go on the cycle. But as soon as the target has been cleared and the graph is just flowing through its natural path, it will go back to the idle as the highest priority. If you don't put the highest priority, by default, the highest priority link is cycling onto itself. It's because a loop is usually what you want as a default. So we would remain in walk even if we remove the target animation. We will remain in the same animation, but we want to go back to idle. And finally, what we want to do is transition from hit. And from hit, we want just to go back to idle. And we don't want to interrupt the hit. We want to play the entire hit and then go back to idle. What happens if we were walking and we get hit? So the graph is just going to find the shortest path to go from walk to hit. And the shortest path is to interrupt, go to idle, interrupt again, and go to hit. So inside the same frame, we're going to jump from walk to idle to hit. And this allows us to use like kind of a hub of animation where you don't have to define all the transition coming from all the animation to all the animation, which like leads to an explosion in the graph. You know, like you see it when you play with finite state machines, and if you have like an explosion of transition, like you have n states, you might end up with n square transition, and that's getting unmanageable. However, here we can actually use a hub animation, which will be all our output animation that are immediate. And if, as long as we can transition immediately inside the same frame to this hub animation, we can dispatch to anywhere else. So to go from walk to hit, we do walk, idle, hit, but the idle will not play. It will just be our hub animation, and inside the same frame, it just will be processed again to hit. So now we have the structure. We have our three animations. We have our graph, and now what we need is to be able to feed the frames for those animations. And we're first going to do it using the textures here. So in order to do this, we go back here, and we remember that this, actually, let's copy that line. Animation, so let's define the idle first. It's going to be the first string and the second string. So in this mode, separate texture files are expected for all the frames. The first value defines the animation base file name. So, okay, what is our base file name here? It's inside our, we need a frame, so it's going to be frames. Then let's start with the lizard. I like the lizards, so there we go. And we want the idle animation. And here, so that the entire animation, entire name for a frame. But remember, we have the base name and the extension of the file. The base name is this. It's frame/lizard f idle anim _f. Then we have our counter, which has no leading digits. Then we have our extension, which is PNG. You can see, so the first value is the defined animation base file name, the second one, the file extension. So now we have defined a way to have the idle animation. We're going to do the same thing for the walk and the hit. So hit animation, and come on, walk animation. I don't want completion. Thank you very much. So it turns out that the walk is actually called run in these sets of files, and the hit is called hit. So that's good. So right now it's going to look for files that follow this pattern, and it will try frame 1, frame 2, frame 3, and so on and so forth until it cannot find the file, and it will stop there. Each frame will last for 0.1 seconds. We're starting with the idle, and I believe that we have about everything we need. So let's try it. So instead of going back to scene every time, I'm just going to expand the child list, and I'm going to add our character here, and let's see if I make any mistakes. Nope, we have our little character, and as you can see, he's playing his idle coming from the files. However, if we look at what is loaded, so there's a command inside orcs, it's called structure log all, and it displays all the everything that is created in memory. So right now, because of the scale, it's not very readable. But if I go in debug, there will be a console version of it. So let's do this. I'm going to bring the console here, and it will have colors. So let's do this. Structure log all. Here, it's much more readable. Maybe the console is a bit too small, hopefully not too much, but you can see that we have a viewport, main viewport, and a camera, and an object scene, which has another object called character, and this character here has the animation set called character AS, and you can see the animation walk, idle, and there's no hit. Why so? And the thing is that, and you can see actually we have errors, fail to create anim hit, can't add link idle to it, and so on and so forth. It's because if you look at that, here it does not start with the digit 1, it starts with digit 0, and it turns out that the hit 1 only has one frame, so it's not found because there's no hit anim f1.png, so it cannot create it. So that's an issue. We're missing a frame here at the beginning. But there is a way for orgs to actually say that we don't want to have those numbers starting from 1, and we can actually change the number at any time. And this is a property called, let me exit. If you go back to the creation template, it's property called frame index, and you can see it at the frame level. This is optional. It's for overriding the current frame's texture origin on the animation frame size and direction. And yeah, this I need to change the comment because it works in textures, I mean in sprite sheets, like what the comment says, but it also works for separate files. So basically, it's the index that you've seen in the beginning, the one that goes from the one I mentioned that goes from 1, 2, 3, and so on and so forth. We can change it per frame. So here, let's say that we have the first frame of the idle animation is going to be called idle 1. We can actually change its real index, and we want its index to be 0. And if we only change the index for this one, the index will keep incrementing for the next one. So it means that idle 2 will use the index 1, idle 3 will use the index 2, and so on and so forth. But we could like we could change the order of frames, saying that idle 2 is actually frame index 3, and so on and so forth. We can change them at any time. But if we do not override them, it will be just increasing 1 from the previous frame. So if we do this for idle, walk, and hit, we should be able to have all our frames. Let's test that theory. You can see that it's, let's see actually, structure. Yes, you can see now that, no, it did not work. So what did I do? I made a mistake. Right, I know why I made a mistake. Because here I assume that the name would be idle1. That is the case when we source from config. However, here we source from files. So the name is actually the entire name. So it's going to be f1.png. That's the name of the first frame. And let's let's make sure that I'm not making a mistake by testing this. And see if we have more idle this time. And idle, we see that we have 4 graphics right now, and we do have the idle anim 0, 1, 2, 3. So this is working. So we have to do it for the other one as well. So basically, let's just do it quick. This one was called, I'm so used to typing Sublime. This one is called run, and this one is called hit. And let's see if it works this time. See? Oh, no, you don't see because I didn't move the window, but there is no errors about not finding the hit animation. And now if we're looking at this, we can see that we have walk, we have idle, and we also have hit. And we see that hit animation, the first graphic, which is called 1, is actually using the texture called 0. It's a bit confusing, but it's because this animation starts with 0. Of course, it's much easier if you make sure that your file starts with 1 and not 0, and you won't have this issue. But at least you can fix it. And you can see now the animation is more bouncy, and it's actually 4 frames instead of 3. And that's what we want. So that covers sourcing from actual separate files. But that's not what we want. We want to work with the actual sprite sheet, which is this guy. So this sprite sheet is organized, and I like the way it's organized because you can see all the characters have the same position, they have all the same anim in the same order with the same number of frames. So that will make our work very, very easy because we can factor a lot of things, and that's exactly what we're going to do. So we are going to remove all this. We have the basic character animation set. We have the graphs that we're going to keep for all our characters today, which is idle, walk, and hit. However, now we're going to create a lizard, and the lizard is going to inherit from character. And what we're going to change is it's saying that the animation set is going to be lizard animation set. Our lizard animation set is going to inherit from our character animation set. Earlier I said we could not, the inheritance was automatic, but it's automatic at the frame and the animation level, not at the animation set, which means that you can inherit manually from another animation set. However, when you define an animation inside the animation set, you cannot do a manual override, because Orcs is going to change the inheritance and it will warn you if you add one. So there will be like a debug message saying, careful, you defined a parent, but that's not the one that we're going to be used, because Orcs is going to enforce making sure that the parent of the animation is the animation set and the parent of the frame is the animation. So here we're going to inherit all this. And the other thing that is common to everything else is the texture for us. And in our case, the texture is this name. There we go. Another thing that is common to everything else is the size of our characters, of our frames, sorry. And if we look at like the elf, I'm just going to open it, 16 by 28, because I don't remember it. So we can say that the frame size is going to be the same for everyone, and it's going to be 16 times 28. So now we define that every frame is 16 by 28, and that we're going to use the same texture for everyone, and every frame and every animations. But we can do more than that. We can see that it's always the same number of frames for these characters. It's always, if I'm not mistaken, 4 idle frames, 4 idle walk, 4 frames of idle, 4 frames of walk, 1 frames of hit. So we can define this here. And if we go back to the creation template here, you can see that the second way to define animation, which was the string int1, we're going to copy it here. Sorry, there we go. The first value, which is optional, defines a name for the animation config template to use. So we can actually override the name of the config section to find. By default, it's going to use the name by itself. So like the idle animation, by default, is going to find for idle as a config. But if you want to override that, you can. You can say that it's not going to be idle, but it's going to be whatever name you choose, and it's optional. If you don't have this, see default to the key itself. The second value, which is also optional, specifies how many frames should be created. And here there's a little trick for that. You can give a positive number, in which case that's exactly the number of frames that's going to be loaded. You can give it -1, and that's as many frames as can be found inside the entire texture. So Orcs is going to like break down the textures into the frame size you give it, and it will just go in the sense of Western reading, so from left to right and then top to bottom, and it's going to punch out all those frames one after the other one. You can actually change the reading direction, and you can put it in any direction, so like vertical first, horizontal first, left, right, up, down, it doesn't matter. And there's actually a property called direction for this, which is here. And it defines how the frames are read inside the texture. First defines the value of the rows, second of the columns, and it defaults to write down, which is the Western writing direction. But let's say that your sprite sheet here, let's say that you had those frames here, and let's say the same characters, but that the frames were defined from the top, from the bottom right, and going to the left direction, frame 1, frame 2, frame 3, frame 4, and so on and so forth. You would say that first direction is left and second direction is up. So it's going to go left first, it's going to start at the bottom right, it's going to go left, and when it's done, it's going to go up and start again. But that's not how your spreadsheet has been defined. Let's say that your spreadsheet is defined vertically with the first frame here, second, third, fourth, fifth, sixth. You say that the first direction is down and the second direction is right. So it will first go down, and when it reaches the end of the line, it will go back and it will go to the right because we said right, and so on and so forth. And we see that we're going actually to use this property a bit later because I made sure that when I created the sprite sheet for the dust effects when they work, I did it on purpose like this to showcase this property. But right now we can say -1, which says as many frames that can fit inside the texture, or you can say 0, and that means how many frames that are defined in config. So this is a property you want to use if you're using something like Texture Packer, especially with the AUX exporter, because it will export a single section for all the frames. If you use 0, it means that AUX is going to look for all the sections, and as soon as it runs out of sections, it means that there's no more frame in this animation. And that's how it works with the Texture Packer. By default, it's -1, which is try to fit as many frames inside the given texture size. Know that the default texture size starts at the top left corner and finish at the bottom right, but you can actually override that. Oops, that's not what I wanted to do. You can actually override that. You can actually define the size of the texture you want to use with two properties. One is called texture origin, and the second one is called texture size. And so if you define a rectangle like this, AUX will just punch out the frames inside this rectangle. And that's what we're going to use here. So basically, we're going to say that the idle animation has 4 frames. The walk animation also has 4 frames. And the hit animations has 1 frame. And this now, we just need to tell it where to find them. And in our character, and this actually is for all the characters, so we don't have to put it here. Like, all this is for all the characters we're going to use. So we're not going to put it at the lizard level, actually. We're going to put it at the character level. It's going to be the same for all the characters. What we want to define for lizard, though, is this rectangle, where to find the little guy here. And we're going to define the texture origin and then the texture size. The texture size, as you see, is going to be the same for all the characters. So all we're going to write at the lizard level is going to be the texture origin. And actually, I do have these values somewhere here so that I can copy paste them easily. And it's going to be I thought I had them. Looks like I don't have them. So we're going to look for them inside the texture itself. Let me just verify. Lizard. Texture origin. Okay. It's 128, 196. So I did have this one here. So let me go back to this window here. So the lizard, the texture origin is 128 times 196. That it seems right, yeah. 128, yeah, 196 seems about right. And we know that there are 9 frames, so 4 and 4, 8, 9 mean that it's going to be 16 times 9, which should be 144, and 28 up. So this is for all the characters, so we can define it here. Like, let's put it here. Texture size equals 144, oops, 144 times 28. So now we have our little rectangle defined for our lizards, and if we do that by default, all the animations are going to start at the corner here. So we have 2 options. Either we defined a separate rectangle for all at the animation, and in this case it's a bit a waste of work because that's a lot of corners to define every time, and it's going to be always the same offset compared to the top left. So what we're going to do instead, we're going to reuse the frame index properties and saying that the idle starts at frame 1, that the walk starts at frame 5, and the hit starts at frame 9. So by default, frame 1 is the first frame is 1, so we're not going to change it for the idle one. However, we're going to say that walk 1, its frame index is going to be 5, and that hit 1, its frame index is going to be 9. So we should have like 4 frames of idle, 4 frames of walk, and 1 frame of hit. And if I didn't make any mistake, we should have a little character working, sorry, not walking, that's not what I meant. And as you can see, it's not at the right place. So let's see what I did here. Let's see. The texture is correct, texture size is correct, frame size is correct, the texture origin, I think it was correct for the lizard animation set. And then we have the walk one frame index, idle. Okay, so let me check what I had in my test project, except that I don't think I have this anymore. Walk, frame index, small walk one, okay, small hit one, frame index also, frame size. What did I do here? Sorry about that. Start animation, small characters, prefix, yeah. Okay, let's see if our debug tells us anything. Anim demo, here we are, starting it. And there is no error, so the errors just come from like bad data. And if we look at this here, we should see it's probably like the top left. Yeah, it's definitely at the top left here, and it's using the frames here. So it's not finding the beginning of the animation. If you spot my error, please let me know. Otherwise, let me just go back to creation, texture origin, texture size, and I have the texture origin. I don't have a typo here. It's 180 lizard eyes. It's a lizard. Oh, yes, I know what the error is. I'm creating a character right now. I am not creating a lizard, and the base character doesn't have the texture origin. Let's try this again. Sorry for being tired. Yeah, we have a lizard now. Okay. The issue of doing live and talking at the same time. Okay, so right now we have our idle. Let's see if we can actually switch it to walk. So object, find. Let's find our lizard. Set animation. Oops. Anim. And let's see, you can go to walk. And it's walking. And you see that if I remove its target animation, it's going to default to idle because we said that idle is the highest priority. So if we remove the target, it's going back to idle, and that's fine, and it's working. So now, what if we want to have like a different characters? That's what we're going to do. We are going to create like I don't know, like a knight. So knight is also inheriting from character. What do we need to override? We need to override the animation set because the animation set has a different texture origin. So we're going to say it's the knight animation set. Then inside the knight animation set, we are going to inherit from the original character animation set. And the only property we need to change here is the origin of the texture. Because for the knight, it's going to be much higher. Let's see if I have the value here. Knight. The texture origin is 128.68. So 128.68. And let's create a knight and see if it works. So we're just going to make sure that our knight is a bit to the right, and that our lizard is a bit to the left. And let's see if it works. Okay, so you can see that it was quite easy to go from the lizard to the knight, and all we had to do is change the texture origin for like punching out our animations. It's because the sprite sheet was made this way. But even so, it's still cumbersome because we have to define like a new animation set every time and like a texture origin, and I'm pretty sure we can actually do better than that. So let's see what we can do. First of all, before doing everything, because I want to be able to showcase the transition from walk and idle, we're going to add a bit of logic to it. And you can see here, by default, we have a scroll object. That's name object, and that doesn't do much. It's almost empty. It only does set a boolean in config is object to true. And this object here inherits from the class scroll object. And the scroll object class allows us to bind directly to config sections, and it also allows us to handle easily some events like on render, on collisions, on this kind of things. If we actually go to the scroll object class, you will see that there's a bunch of accessors that are helpful to do this, and then some events that are wrapped as well. Sorry, so like on render, on shader, on collide, on sprite, or even for like new animations and things like this. So it's a convenience wrapper, and every time a section that has been bound to this class is used to create an aux object, the scroll object will be created as well. And how this works is if we look at our little game, there is a function called bind object. This is executed at the beginning of the application when it starts. And what we do here is that we bind the class to a config section. That means that any object, aux object that is created based on that config section will have a scroll object of this type created and linked to it automatically. And this will happen no matter how the object is created. It can be created through scroll, it can be created through aux, it can be created through like a spawner automatically internally. Every time it will happen, the scroll object is going to be bound and initialized with it. And it also works with inheritance, meaning that any object inheriting from this section here, any section inheriting from this section will also be will also have like an instance of that scroll object going with it. So in our case here, if we go back to our little animation demo here, we can see that we have characters and we have like lizard and knight inheriting from character. So let's not create them right now. Let's just start like this. If we go into the config, we have not created anything. So if we get lizard is object, you can see that it says nothing. And same thing for knight. There is no config property inside the knight section is object. However, if you remember here, our little class here, when it's created, it's going to set the property is object inside the section of this bound to this class, and it's going to set the value true. So now if I'm creating a knight, and if we ask get knight is object, this is not working. Okay, fair enough. Let's try this again. What did I mess up here? Knight inherits from, oh, it's, yeah, okay, fair enough. So nothing has been created because it's inheriting from character and not from object. And we said that our class is object. However, if we say that character now inherits from object, that will be different. So first, get knight is object, there's nothing. Now if we create the knight, and if we ask it again, you can see that it's set to true. It means that this class object has been instantiated, and the onCreate has been called, and when the object is going to be deleted, onDelete is going to be called, and every frame the update function is going to be called on it. And we're going to use the update function to add some logic to be able to move our character. In order to do so, I'm just going to copy paste some code from previous live session. If you remember, there was a project called Mix and Match, and we had like characters moving. I'm just going to copy paste this small amount of code because it would be a bit too long to just type it and not very interesting. This is not the topic for today. So I'm just going to put it here, and we can go over this. So that's not much code, as you can see, and we're going to simplify it even more. We are pushing our current config session because every read and write we want to do it inside the config session.com. So like from the knight, from the lizard, and so on and so forth. And at the end of it, because we push the section, we also want to pop it. Symmetry. What we're going to do here is that we're going to retrieve our current input set and back it up for later. We're going to restore it when we're done because we're going to change the input set and use the one that is named after the current section. So we need to create that we need to activate this input set. So we don't really need this. However, what we need is that at the beginning, when the object is created, we're going to say enable set, thank you. And we're going to enable a set based on the same name of the config session. It doesn't have to be the case, it's just that it's convenient. This way I can put my input inside the same section as the object itself. And we're going to set it to true. And the fact that we enable this set means that it's going to be updated every time as long as the set is enabled. So we're going to have like a night input set that's going to be enabled when a night is being created, and then we can pull its values directly from here. So that's what we're going to do. We can only pull the value from the current selected set. So it's like a config section. You know, when you push a section and a pop, you actually select a section. It's the same thing with input. We're going to select our current input, and then we're going to restore the previous input. This way we can just query what we want. And we can also reuse the same name for the inputs, which is very versatile and allows us to have like the same name for all our characters instead of having different names, or for all our players, and also to use like virtual input to move characters programmatically or through command. If you look back to previous live session, we went a bit deeper into this. So we want an animation. By default, we are not giving any animation. We want the graph flow to flow naturally. What we're going to find, what we're going to retrieve are 4 inputs: move right, move left, move up, move down, and we're going to build a vector based on this. So we're just going, those values are like normalized. So basically we're going to have something between 0 and 1 minus something between 0 and 1 for the left. So if it's entirely left, it's going to be -1. If it's entirely right, it's going to be +1. And if both are pressed at the same time, it's going to be 0 and you're not moving. Same thing for the vertical. So we have a vector that is our input vector. If it's not null, what we're going to do is say that we want to work. So we're just going to change our animation and say we want to work. We're not going to do any of this that was part of the last test in mix and match, because we had characters that could orient into 8 direction. Here we don't want to change direction, we just want to play different animations. So however, we want them to move. So what we're going to do is we are going to we're going to multiply our move vector by a value that we're going to define in config. So our config get float, and we're going to call it work speed. So we can override the work speed at the character level if we want. Like we can have a different work speed for the lizard, a different one for the knight, and so on and so forth. And we are going to apply the data set speed here. And lastly, we're going to play the animation. So we don't have to do this. All we want to do this time is call the animation. And we don't want to override the current animation. We want to set it as a target so that the graph flows correctly and that the current cycle finish when it should finish, and so on and so forth. But we're going to apply it on all like sub-objects. We don't have any here, so basically I could remove this, it would work the same. And that's it. So it's a very simple logic, and that's all we're going to do with this. So we're going to build it in release and in debug. If Visual Studio, okay, there we go. And that's the only change we're going to do in code today. So we need to define a work speed though. So we're going to go into animation demo, and we're going to give a default work speed to all our characters, and 200. I don't remember what value is good one, so let's see with 200. So now we have inputs that are pulled, but we haven't bound those inputs to physical presses. So let's do this. We're going to say that our lizard is going to use WASD. Oops. And so W is move up, A is move left, S is move down, and D is move right. So let's see if it works. Oh, let's create our little guys. And you can see I can move them. One is not moving, is playing the idle. One is moving, is playing the work animation. And we're going to do the same for our little knight, except that for knight, instead of having this, we're going to use the up arrow, left arrow, down arrow, and right arrow. And now I should be moving. Oops. Why did I make a mistake here? Oh, I put it in the animation set. Whoopsie. There we go. There we go. Now we can move independently our little characters, and you can see them move. But again, if I wanted to add like an elf, right now I would have to define a new animation set and a new position, and so on and so forth. Let's see if we can be like a bit more efficient for that. So, if you remember our sprite sheet here, everything is well laid out for us, and it's quite nice in that sense. However, we can simplify something. First, we can use the same name section as instead of defining like a separate one for the animation set. That's an easy change for a good bang for the buck, is that instead of having animation set as a character, we're just going to use ourselves here. That means that we're going to use the same section to define all the properties for the object and the animation set. So if we do this, it means that we don't have to do this, and we can just put this here. And you can see the texture origin is inside. I'll just put it here. And same thing for the night. Okay. And
there's a question.
Yes.
Is the key underscore thing part of scroll? Usually I have those declarations in main input.
No, they are part of aux. Scroll does nothing with the key. Let me actually look at the question itself. If I go to the live, there's a text channel, right, for the how is this working? Sorry, it's been a while. Okay, there we go. It's not part of scroll, and you don't have to put them in main input. Main input is like if you want just one set and have like one place and not switch sets. The advantage of having multiple sets is that you can handle multiple characters with the same inputs, like you can use the same names and you just switch from one set to the other and keep the same name. And you can do the same thing for like a menu, for example. Like in a menu, you don't want the same key press to trigger like, I don't know, like an attack or something like this. So instead of having separate names, you can reuse the same names and just have separate sets, and you can enable them and disable them on the fly to make them effective or not. It's actually how the console works. If you look at, if I go back here, oh, sorry, I don't see my screen anymore. If I come back here and I move the character, if I create the console, you can see that now I get the inputs here too, because the two sets have been active here. The character set and the console set. But if you just run regular aux, once you trigger the console, all the input will only go inside the console by default. Because here it's just that in our character we don't check what the current set is. We're just always enabling our sets and we force it. So that means that even if we're in console, it's going to move. But otherwise, if you just use aux and if you use the bounce one, for example, and you pop the console, you will see that clicking will not do anything anymore because we're going to be on the console set. And there's a separate set as well for the profiler. The profiler, you can have, let's see, set render show profiler 1. I mean release. So let's go in debug. Okay. So sorry, this window is in my face. There we go. Set and show profiler 1. Here in the profiler, there's actually a different set that allows me to do something like I forgot the keys that I chat. Okay, that's pause. No, wrong one. I'm sorry, I don't remember the keys that I set for displaying. Oh, this is for channeling, so that. But you can see there are keys to handle the profiler, and there's also a key like there, enable the graph, and something. So like for pausing, navigating, and this kind of things, it's a different input set. So this way you don't have to like have just one input set where you have to make sure that you don't conflict with your inputs. You can have multiple ones, and you can enable and disable them at will at runtime, and it's very useful. So like for example, if I press escape in the console, it's not going to exit. However, if the console is not here and I press escape, it's going to exit. Hopefully that answers the question. So in this case, I'm just going to use the name of my characters as an input, and you don't have to define the input sets anymore. Like a few months ago, you still had to define the list of input sets you wanted to use, and you had to define it inside the main input or input. Input, you had a set list. Now it's not the case. Every time you have you try to enable a new set, it's going to be added on the fly if it wasn't already known by orgs. So it's more flexible this way. Okay, so as you can see here, we have the night. Okay, an animation set. I have to remove it. That's what I was doing, and you can see it's still working. But I do not have to have two sections every time I want a new character. The only thing, if I want like I have an elf coming from character, is just saying that texture origin, and I give it to it, and it's going to work fine. And let's create the elf, and let's texture origin for the elf is, let me copy the value. Elf, it's 128.4. So texture origin 128.4. So if I do this, I should have an elf, except that the elf cannot move because I bound it to no input. Now we're going to see how to work with things that are not that homogeneous. Here it was super easy. Everything was in the same texture with the same layout, exactly the same number of frames, the same size, so we could put everything inside the animation set. But even if it's not the case, there are still ways to make it efficient, and that's what we're going to see with a new set of characters. So before everything, I'm just going to have these characters. No, actually, I'm just going to add new characters. So let's look at what we have for the new set of characters. New set of characters, it's going to go into texture, kings and pigs, and we're going to look at the king human first. And you see that now we have separate texture for every animations. So that's already something different. And you can see that the size here is the same for these characters, but if we look at another one, which is a king pig, you'll see, oh, he has different size as well. And actually, it also has a different number of frames. So we cannot rely to the kind of pattern we had before. But Hogs will still help us with this. So we'll see we have an idle texture, we have a run texture, we have a hit texture. So we're going to use those. Sorry. So in order to be able to reuse this part, we're going to separate what is common from those characters and the new ones that we're going to call king characters or big characters, and what was only for the tiny ones. So for the tiny ones, basically it's these. This was what defined how the animation was laid out in the atlas, in the sprite sheet. But this is actually common to everyone. We want to keep, we want to keep the same key duration because they are still at 10 Hertz. We want to keep the same graph, meaning we have idle, walk, and hit. We want to keep the same base. So all we're going to do here is we're going to separate this as a small character. And the small character inherits from the big character, from the regular character. And now we just have to make sure that our lizard is a small character, our knight is a small character, and elf is a small character. So if I do this, normally, it should still be working. So far, so good. What else? Here you can see that we did override walk and hit the frame index, and we don't want to have this carry over to our big character. So what we're going to do is we're going to add a property. So here, for example, the idle and walk and hit, what we could do is give a different name, saying like idle would be small idle, and then walk we could say it's small walk, sorry. And here I could use small walk, small hit, small idle, but I don't want to have to do this for all the animation. Right now I only have 3 animations, that's fine. But if I had dozens of animations, that's not a good way to do it. But what we can do is that we can use a prefix. And if we look at the creation template, here you can see that the prefix that will be used in front of all animation names and frames. And by default, it's empty, it doesn't exist. But that's what we want. We want everything be prefixed with the string small. That means that instead of having small walk, we are instead of having walk, we're going to have small walk, and same for the frame, same for the hit, and same for the idle. Small idle one. Though in the case of idle 1, the frame index doesn't change, we don't have to put it. So if we do this, normally it should still be working, sorry, and they are working. And now we can actually inherit without with the big character, just inheriting from this, but not from this. And that's what we're going to do. Let's define our big character coming from regular character. So by default, we have the same kind of thing, except that this time we want to define idle, walk, and eat separately. And remember here the name of the texture are different between all the characters. So we don't want to put it at the level of the big character, but we're going to have another inheriting, like saying like king human inherits from big character. And inside king human, we're going to use the prefix king human. Because, I'm sorry, my OCD is triggered a bit. There we go. And we're going to have the prefix king human, means that right now we can define properties for just this. So let's start with the idle. The idle is going to be king human idle. We want to define the texture for it. And the texture is going to be 01 dash king human, oops, yeah, the space human idle dot png. That's the texture that's going to be used for the human idle. However, we see that all the frames are the same size everywhere. It's 78 by 58. So this we can actually put at the animation set level, which is here. So we're going to say that the frame size is 78 times 58. Oops. So here we go. We have the idle defined for the king human. We have the correct frame size, and I believe that's all we need for this. Let's just try to see if it works. And king human. Let's see if we have a king human with an idle. Yeah, look, it's playing his idle. Let's continue. Let's give him like a walk and a hit. King human walk and king human hit. And I believe it's called run and hit. Run, hit, and let's see if it works. So right now, instead of having, like, I'm going to put the set of 3 tiny characters on the same inputs. So I'm going to put this at small character level. All the small characters are going to move with WASD. And I'm going to do the same thing for the big character level. I'm going to move them all with my right with the keys. And let's see if it works. So my little characters move there, and as you can see, is moving. And let's see if the hit works. So object find. Well, you know what? Actually, let's. No, it doesn't really matter. Just to test if it's working. I'm going to move him a bit though. Position. We're going to go a bit higher. There we go. So let's object find our king human and object set anim. We're going to set its hit, and you can see that it plays the hit animation and is going back to it. Let's put it in a walk cycle. Oh yeah, but we have our code running, so we cannot do it anymore. I would have to actually move it like this. So let's it's a bit tricky. I'm going to move, and I'm going to ask for the hit at the same time it's moving, and you will see that it still works. We're going to go through the idle hub animation, and it will still play the hit. So I'm still pressing walk, playing the hit, and it plays the hit, and it went back to walk after. So this is working. And now if we want to override this for a king pig, that's going to be a big character as well. What we have to do is give it these properties. So we want to put it let's put them on the same line. Oops. let's see what our king pig is made of. If we look at the king pig, we can see they are all 38 times 28, so we can put it at the animation site level. 38 times 28, and we're going to give a different prefix, which is going to be the king pig prefix, and we're just going to define the animation for this. King pig. I wish I could just do the replace, the advanced replace from some light text, but it's okay. 02 pig, 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 and that was 3828. 3828, 3828, and let's see if this is working by adding a king pig. Yeah, see? And you can see the idle is not the same length as the king because you have different number of frames, but it still works because Orcs is just only picking on as many frames fit inside the texture by default. And that's what's happening here. So keep in mind that these kind of things can actually be generated at runtime, and that's something I covered a bit in the past live session with the mix and match project. There was a version of handcrafted data, like config data, which is very long, and a version that was semi-procedurally generated by just taking some hints. And you can do the same kind of thing here. You can see that here it's always the same kind of prefix and the same, it's reusing also like the frame size. So these you can generate on the fly, and you can generate all the section and the content on the fly before creating your character. So it's like a pre-processing step when your game starts, and that prevents you from typing all this manually and makes your life much easier and also much less error prone. And you can push it as much as you want, but I'm not going to do this in this example. What we're going to cover right now is more like synchronization, like if we want to have like dust effects when they walk and like sound as well. That's what we're going to cover right now. Are there any questions right now so far with what we covered? I will take that as no. So let's create.
Just a moment.
Okay, sorry.
Looks like you're getting one within the Discord chat.
Okay. Well, I will wait for that, and in the meantime, what I'm going to do is go look at the texture we need for. That's not this. The texture we need for our footstep effects, which is a smoke effects light and this guy.
Oh, I see. Someone was just saying, good so far.
Excellent. You can see that this texture, as I mentioned earlier during the stream, I organize it differently. So the animations are not horizontal in this one, they're actually vertical. I mean that this is one animation for dust effects, this is a second animation, this is a third animation, and so on and so forth. In the fact, I realized later that it's not going to change much because we're only going to use a single column for one effect. But if, let's say that one effect was 3 columns, we can have them read like vertically first and jump to the right and vertically and so on and so forth. So we'll still do it like to show how direction works. But in the fact, given that we only have one single column, technically it doesn't change much. What we're going to do is that we're going to take 3 different effects and have them randomly popped under the feet of our characters. So because I already did some work on this, I'm just going to copy paste the smoke section, and we're going to reuse this instead of me typing it and take too much time for this. So we have a smoke section. We're going to, well, there's a position has been said. We're going to scale it down, and right now, let's remove the scale. We're saying that we're using the current animation set. And here you see that we are not using the start anim property, but the start anim list. I will come back to it right after. We are going to start with the start anim, just a single one, and call it smoke1. And here you can see that we say that smoke1 will transition to nothing. If we didn't put anything, smoke1 will transition to smoke1 and it will just be a loop forever, like we had with the idle on the characters. If we say you transition to nothing, that's what's going to happen. At the end of this animation, no more animations will play on this character. It will be stopped. And this is important because the smoke, we want it to appear and then disappear when the smoke effect is done. And we don't have to write code for that because orcs can handle it for us. We can see that it's in the texture called smokefxlight1a.png. We can see that, that this is the size of a column, so it's 64. Each frame is 64 by 64, so it's 64 wide for one effect, and there are 10, no, actually 9 of them, so it's 576. So those are the things that are going to use. We are going to see that we're going to play them also much faster at 20 Hz, and this is what's interesting. So these properties here between these, those are the animation set properties, but this is also animation set properties. Direction, we say that we want to go first down and then right if we had multiple columns, but we only have one column, so it's a down that is important here. And this we go back to like object properties. So I'm going to put them at the top to make it more readable. At the top we have the object properties here, and here we have the animation set property. So we are not going to do this first. We are going to do this one here. Here you can see that there's a lifetime set to anim. If I didn't put this, and if I didn't put this here, let's see what happens. We're going to create a smoke, and it's behind our character. And you can see that the smoke is there, and it's looping forever. Now if I said, okay, fair enough, we want to create the smoke, it plays once, and then it stops, and it remains on its graphics, which is the first frame by default. But it's still there. We don't want to keep it there when it's being played. So what we want to do is set the lifetime property to anim. I mean that once there's no more animation playing on this object, it's going to be deleted. And we can actually even like confirm this by doing the remember the structure log all. Yeah, I need to put in debug so that it's readable in the console version. So if we do the log all and we look at it, we can see there's a bunch of things we've created so far. However, we can see that we need to create the smoke first. Create smoke. And if we do the log all this time, for real, we can see that there should be a smoke. Where is it? Object, elf, king human, king pig, lizard, smoke. We have an object called smoke, which has an animation pointer with an element called smoke1, and it has a bunch of frames, smoke1, 1, smoke1, 2, 1, 2, 3, and so on and so forth. And it has a graphic, which is the entire texture, and it's using the same smoke1 as a default graphic. But the object remains when it's done playing the animation. However, you know what? I'm going to remove the character just to make it a bit less child list. I'm just going to up. There we go. However, if we were to so just verifying it still works. Smoke, log all, and it's much more concise. The smoke stays here even after it played. If we were to set the lifetime to animation, and now I'm creating a bunch of animation, you see they disappear when they're done. And even after creating like a few of them, if I log everything, you can see that there is no trace for them. They have been deleted as soon as the animation is gone. Right now, by default, all those frames would be reloaded from disk every time they are not in memory anymore. So we don't want this. We actually want them to remain in memory. It doesn't really matter for this test, but you can use the KeepInCache on the animation set, which will then be used by every frame, and every frame will be kept in cache if you want it this way. If you don't want to keep them in memory when they are not used, that's also fine enough. But know that any frame is a graphic, and there is nothing specific about that graphic. It's a graphic as any other graphic. It's just that they are used in rhythmic sequences. So we have one smoke. Now, how do we want to have multiple? How do we get multiple smokes? We're going to define 3 smokes, and that's where the start anim list is going to be useful here, because we don't want to define a graph. It's not like we're going to go from smoke 1 to smoke 2, and then maybe back to smoke 1 and then smoke 3. We just want multiple smokes inside the same thing. One way would be to create one animation set for every smoke, like we did for the different characters. But it's also much faster to just create them here and have different animation. And they are separate animation that are self-contained, and they are not connected inside the graph. They are island inside the graph. So like you see that any of these animations are just stopping after they are going to play. That's fine. So Orcs is going to create them all based on the start anim list property. And I believe if we go to creation template, you can see that there's a start animation list, and it says multiple entries point for disjointed animation graphs. The first animation in the list will be played by default. So it's not a random one that's going to be played by default. It's always this one here. This I might change maybe later, but right now that's the behavior. So how do we get a random one? Well, let's just use command on create. So when the object is going to be created, what we are going to do is we're going to retrieve the name of the object. And we're going to push it on the stack. Then from this name, which is smoke, we're going to retrieve the value from start anim list. And start anim list is a list. We did not give an index, means that we're going to get a random value inside that list. And that random value is going to be pushed on the stack, which means we'll get either smoke 1, smoke 2, or smoke 3. And then what we're going to do is we're going to set the animation of the current object with the value we got, and this says override the current animation. So when being created, we get randomly smoke 1, smoke 2, or smoke 3. And let's see what we get. Sorry. And you can see it's a bit different every time it's random. And that's what we wanted. So every time we're going to create a smoke, it's going to be a different smoke. And that's exactly what we want. So now how do we synchronize the smoke with our characters? So let's put our characters back here. Let's start with a small character. We want to do it at the small character level because they all have the same pace of putting their foot down, which is on frame 3, I believe. Let me actually double check if that's the case or not. Yeah, I'm sorry. So if we look at this style set here, little guy, frame 1, frame 2, frame 3, no, it seems like to be on frame 4. Yeah, I would say it's frame 4 for, oh, that's an idle. 1, 2, 3 contact, 1, 2, 3 contact, 1, 2, 3 contact. Yeah, okay, it's on frame 3. So what we're going to do is that instead of doing it for the lizard, the knight, and the elf, and we know it's the same for all the small character, is that we're going to add a custom event to the small walk 3, which is the third frame of the small walk animation, which is going to be inherited by any lizard walk, any knight walk, any elf walk. That's why the orcs is doing automated inheritance, so that you can have this system and you can inherit from this kind of tree, like the specific animation from the generic animation, the specific frame from the generic frame, which inherits from the specific animation from the generic animation, and then from an inheritance set. This entire tree of inheritance is made for you when the animation set is created, but it will not persist, so it's not going to remain in memory. It's just once it's going to be processed. So here we want I don't remember the properties, and that's why we have a creation template. We want a key event, which is our custom event. We want the key event, and here it's an event that you can capture inside Orcs, like any other event. But if you enter like a command, the command is going to be executed, which is a nice shortcut, in that you can do anything here. So let's try something. Let's try to create a smoke. In that every time we're going to set foot down, at the third frame, we're going to create a smoke object. Let's not put it in debug, but in release, because every time I have Windows popping in my face otherwise. And you can see, oh yeah, fair enough, it's created, and it's living its life, it disappears, but it's in the middle of the screen. Okay, fair enough. We're going to retrieve this object, and we are going to set ourselves as parent. So object set parent ourselves. Let's try this. Yeah, that's good. But you can see the scale is not good. That's why here I had a scale on the smoke, and it's a bit better, I believe. Yeah, it's much better. However, you can see that the smoke effect moves with the character, which is kind of jarring, right? It's spun under their feet, then it moves with them instead. We want them to leave it where they are. So what we're going to do, and where did I put this? Key event, thank you. Instead of doing this, once we have attached it, once we set ourselves as parent, we're going to detach this object. Oops. And by detaching it, we're just going to leave it in place. That's much better. We leave our trail behind us instead of having them follow us. So now we have our little smoke. What if we were doing the same thing for like the big characters? So instead of doing this in the key event, because maybe we are going to use it on multiple events, you don't want to copy paste this every time, we're just going to define something like in a game section. Let's say, yeah, let's put it here. Let's say, or we can define it in FX section. In FX section, we want the smoke event, and here the smoke event is going to be, why not just calling it smoke? It's even faster. Okay, FX, smoke, and we're just going to take all this. Okay, so now every time we want to have like a smoke created, all we have to do is I want FX smoke. There we go. So now we can do the same thing for the big guys. Let's look at the big guys. We have the king humans, so we are going to have to look at how the king human is made. I went too far. Sprites, you want king humans. And let's look at its run animation. And the king humans, 1, 2, 3, 4. I would say 4, there's a footstep here, and then is going back up. Let's put just 1 on 4. So here we're going to go to the king human, which I put it here, and we're just going to override the first frame. King human walk 4, and the key event is going to be FX smoke. So now, but you can see that actually let's put it on 2 frames, like maybe 1, 2. Yeah, but you can see the position is not where we wanted, and the offset is not the same as this little guy. So how about we do something different here? We have a smoke here with an offset, and let's create a big smoke coming from this with a different offset. So we're inheriting from smoke, except that for the position we're going to do something different. So let's start with 0, 0. And we're going to create a big smoke as a big smoke event. If we go back here, we add a smoke. And instead of smoke, we're going to create a big smoke. And this time we're going to create big. We could be smarter than hard-coding everything here. Instead of hard-coding this value here, we could, for example, retrieve the name of the current object and retrieve like property inside it, and that would be the smoke. And that's something we can do actually. Maybe we'll do it after. But right now, let's just be like the dumb approach and the most straightforward. We're just going to have an fx called big smoke that's going to create a big smoke. So instead of having fx smoke here, we're just going to create a big smoke. And because in debug by default we have auto reload, you can activate auto reload in release. Just make sure to remove it when you ship your game. we can actually tweak the values on the fly. So let's see. It's still too low. Let's see if it works, if I did my job correctly. So, yeah, it works. See, now it's higher. It's a bit too high, maybe. -8. Let's say it's good for our purpose. Yeah, it's not perfect, but you get the gist of it. Basically, you can override it in debug on the fly and test it and see what it does. And now we have a big smoke versus a small smoke. And maybe that in the big smoke, we want to override the scale of the small smoke and put it back at 1. And then we have like big poof of smoke for the king human. After all, is the king. But you know, okay, we have this. Let's talk about like we want sound as well. Well, same idea for sound. What we're going to do is create a footstep. And let's see if I have some pre-made config for the footstep.
There's a question about the smoke animation.
Yep.
Can you mirror the smoke animation when going the other direction?
Yes, of course. You can do it by scale, actually. You can inherit from the parent scale, and then it's going to be like right now we don't change the animation for the parent, but what you could do, either you define a different separate animation for like walk right and walk left, or you can just do it in code and change the scale of your object. And when you're going to do the set parent, you know, when you attach the smoke, well, it's going to be inherited as well. So the smoke is going to be reversed. Actually, let's see if my theory works by testing it. Like, okay, we have the king. Oh, this window in my face. We have the king here, and you can see that the smoke, oops, not this guy. The smoke is like this. Let's object find king human. Object set scale, king human. We want to reverse it horizontally but not vertically. Oops, and it was actually 4, I believe. So let's put it back to 4. Okay, and now if I move, you can see it goes the other way around. It's because when we create it, we set the parent as object, so the smoke is inheriting all the properties from the parents, including the scale, the position, and the rotation. We could ignore them by using the ignore from parent property, but by default, they are inherited. So you can see that the smoke has changed, and you don't have anything to do. It's just by setting it as a parent and then detaching it, your smoke is inheriting everything. That's also why the smoke is inheriting the 4 times scale. If we were doing something different, like in the smoke here, if in the big smoke we said ignore from parent scale, this is not going to work anymore. First of all, again, sorry, I have debug window. First of all, you can see that it's tiny, but now if I actually reverse it, it stays in the same direction because we told the smoke to ignore the scale from the parent. So even when we are setting the parent at open creation, well, the scale is not going to be affected. But by default, it does it. Does this answer your question? So, footstep. Let's see what I have for footstep. I believe I had a few things. Yeah, let's just go over this. We're going to create a footstep. It's going to be a sound. The sound list is going to be itself. KeepInCache, it's, yeah, again, you can use it or not depending on your needs. We're going to have a random pitch every time a sound is going to be created. It's going to be between 0.8 and 1.2 times the original frequency. And we're just going to make it not too loud. So let's start at 0.5. Then we're going to create 3 different footsteps. Footstep 1, taking the sound from this one. Footstep 2 is going to take the sound from grass, and the last one from metal. So now if I were to create those, I'm going to stop doing the debug because every time I have a window that pops in my face that you do not see on the other screen, and release doesn't do that, so I can see what I'm doing. So, object create footstep 1. You can hear the footstep with different pitch. 2 is different, and 3 is completely different. Let's say we want random footstep, including like the random surfaces. What we're going to do is we create a random footstep. We define the list of footsteps we want, and we're going to define a child that's going to be a command, a lazy command. Every time a random footstep will be created, its childlist property will be retrieved, and the childlist property will actually execute this. And this says push the current section. Here it's random footstep. And inside the current section, retrieve a value from this footstep list. And because it's a list and we didn't give an index, again, it's going to be a random value inside the list. So footstep 1, 2, or 3. So this object will be a child, will have a child which is either footstep 1, footstep 3, or footstep 3 randomly. And we're going to give it a lifetime, saying that once the child is dead, you remove yourself as one. Which reminds me that here we didn't set a lifetime, in that they are going to linger even if they don't play anything. But if we place a lifetime of sound, every time the sound is over, the footstep is going to be deleted, which in turn, this guy will be childless, and because he has no child, is going to be deleted as well. So if we were to create a random footstep now, random footstep, you can see it's completely random. And if I go back to the debug to showcase that we are not polluting our scene with objects, with leftover objects. Oops. Pardon. Random footstep. Sorry. And now if we're going to look at all the structure, we can see that we just have the graphics of all our objects, lizard, king, pig, scene, night, but we don't have random footstep lingering. It's because they have been deleted when the sound is done playing, and the parents have been deleted when it doesn't have any children. Okay, there we go. So now we just need to place the footstep. And remember, we already put like the smoke effects. We want to play the random footstep at the same time. So instead, we can just put it in the FX. And instead of having FX smoke, now we can just have FX step. And for the big smoke here, we're going to have FX big step, for example. Oh, actually, you know what? We're going to do the refactoring we said earlier. We're going to use a step 1 for everyone. What this is going to do, it's going to retrieve the proper smoke and play a random footstep. So in order to define what is the proper smoke, we're going to go into the base section for the king human and the king pig, which is called big character. And here we're going to say that the smoke 1 is going to be big smoke. And for the small characters, which is defined here, we're going to say that its smoke is going to be just smoke. So now here in the effects, instead of having this, we're going to have step. So step is going to first create a random footstep. Random footstep. Then it's going to be something similar to this. So we're just going to do this. However, it's not exactly to be just this. We first need to retrieve this value. In order to do this, we're just going to retrieve the name of the current object. And we're going to push it on the stack. Now we have the name of the section. So that's where we define the smoke property. So we're just going to get, from this section, we're going to get the properties called smoke. And we're pushing it on the stack. So now we have the right property here. We can pop it from the stack. It's going to be either regular smoke or big smoke. And the rest is the same thing as before. So if I didn't make any mistake, let's verify fixed step everywhere. And I define the smoke property for the big character and the smoke property for the small character. Let's see if it works. Oh, I have again the debug. There we go. And this is working with small, and this is working with big. And the same way, instead of having random footstep, we could also retrieve the actual footstep from the character, and we could even like have a lookup table depending on the current surface of the character. So if it's grass, we would play something different. If it's stone, it would play something different. This is just an added layer of indirection, and we can use the config section for these kind of things. That's what we did for the smoke, actually. We could just add like an extra indirection based on the properties of the current, on the surface under the current character. So yeah, basically that's what I wanted to cover today. Do you have any questions? I know that this session has been a bit longer than usual. We're already at 1 hour 40 minutes. But if you have any questions, either related to the animation system or to anything with Arcs, really, now is the time.
There is one within the chat.
Let me get back to the chat. Okay. KeepInCache should be suitable for the sounds too, otherwise it would load the audio from disk each time. Exactly. Unless the audio is currently playing and still in memory, it will be reloaded from the disk every time. That's why maybe like again for sounds, you probably want to keep them in cache. If you're using the stream though, they are not kept in cache because stream is by default it's streaming from the resource storage. Like for music and things like this, you don't want to like put something like a few megabytes or 100 of megabytes in memory. They're going to be streamed like with tiny buffer from disk every time, and that it's going to happen on a separate thread. So it will never impact your logic or your timing of the logic. That being said, for texture, sometimes you maybe you want to flush all your characters when you're changing the scene, and you can flush the cache. I know we had discussion in the past about the caching, and I want to improve on this. I want to make it more modular than just flush the entire texture cache or flush the entire sound cache, which you can do right now. It's programmatic. You have a function to do this, but I want to be able to have like separate caches and have a better strategy for handling what you want to keep in memory and what you don't want to keep in memory when you're not using it. I still need to think about it because right now there's also the concept of stasis that is coming for like graphics and probably for other resources as well, which allows you to like create like a large amount of object in memory, like millions of objects in memory, and just put them to rest. And if you put them to rest and the stasis is defined on them, their actual resources are going to be unloaded from memory and reacquired if you want to wake them up. So it's kind of like streaming behind the scene the resources for you, so you don't have to do this kind of bookkeeping. I believe it's something that Joe is going to use for his game already, but it's in the development branch. It's not part of the main branch because I still need to expand this concept not just to graphics, but to other resources as well. But yeah, KeepInCache would be suitable for sounds too, if that answers the question. Any other questions? Well, thank you very much for your presence. Thank you, everyone. Sorry about having a second take for this one. That last time didn't work really. It was a shame. But hopefully in the future we won't have this kind of hardware issues. And I wish you all a good day, good evening, based on where you are. And I'll see you in the next live. Have a good one.